Hello everyone, welcome to another video in this tutorial series. Where in this video we'll be looking at creating our restaurant backend using our MongoDB along with TypeScript and Node.js. If this is your first time, then it would be beneficial that you go through and watch the previous videos, as this is a part of a full stack Flutter development series. But here we'll continue to look at our restaurant backend, and in this video we'll be looking at creating our restaurant module, looking at creating the repository and also our restaurant domain objects. So I will get right into it as we'll go into our source folder and we'll create another folder called restaurant. In this folder we'll have the necessary objects relating to our restaurant, and here I'm gonna create another folder called domain, and inside this domain folder we'll have our restaurant objects and those classes that relates to our restaurant. So I'll go ahead and I'll create a restaurant class. I'll go and export this as a default class. And for our restaurant inside the constructor, I like to have a few properties. There needs to be an ID, which is of type string. There needs to be a name property. I'll make all these properties public. There also needs to be a type of restaurant. In this case, type represents whether it's a fast food or Chinese or whatever restaurant that is. We have a rating. This will be of type number, and we'll have a display image, URL. This is a string. We'll have a location, which I'll create a location object for that, and also the restaurant address, and I'll create a address object for that also. So all these should be public. Then I am going to make these read only. As you can see, we didn't give our class a name, so in this case it is restaurant. So now we need to create our location object and our address. So I'll create them here at the same class address, and our address will have, again, I am creating this address based on how addresses are structured where I am. So you could use the way address is structured where you are. public read only. We'll have a street, then we'll have a city, then we'll have public read only again, and all these variables will be read only, so that they're only created at first through the constructor and will not be updated through any setter methods. Public read only, and I'll have a zone. That's my address object, and I'll go ahead and create my location. And the location is quite simple. We'll have a longitude and a latitude. So public read only longitude, and also the latitude. And each of these must be of type number. So we'll go ahead and create those. Next, we will, inside of our domain, we'll create our restaurant menu. So menu, and for our restaurant menu, we'll create our menu class. Inside of our constructor, we'll have the properties of our menu, which we will be storing. Each menu has an ID. There's also the restaurant ID for that menu. This way we can know which restaurant this particular menu belongs to. We have the name of the menu, and some other properties. Then we'll have, lastly, the menu items. In this case, it will be an array of menu item. And we'll go ahead and create our menu item class. For our menu item, we'll have our identifier, we'll also have our, in a sense, foreign key, in this case, which will be the menu ID, which ties this menu item to a particular menu. We'll have a description of this item. We'll have image URLs, so if there's any images to be stored on this particular menu item, which will be an array of string. And we'll have the unit price. Now you can add other properties to your menu item as needs be, but for now this is what I have for my restaurant menu. I'm also gonna go ahead and create a pageable class, and This class will wrap a set of restaurants that will allow us to paginate throughout those restaurants, so that we do not bring back all the restaurants from the database at the same time, but we can easily paginate through those restaurants. I'm gonna say pageable. This is gonna store somewhat the metadata on each page and the list of restaurants associated with that page. So I'll export default pageable. And this is going to be a simple class that stores the page number. So in this case, the page that we're on. I want it to store also the size, the page size, and total pages. And finally, our list of restaurants. But I am going to make this a generic type. So it's a generic type T, and then this pageable will accept a generic type. So there we have our pageable class. So now, inside of our domain still, I'm gonna create another class. Well, this time it's gonna be an interface, which is gonna be the interface or contract for my restaurant repository. This repository will hold those methods that will be available. This contract rather will hold those methods that will be available to my restaurant repository, so that anyone that implements this contract must create those methods, or anyone that subscribe to this contract. So I'm gonna have a find all method. And again, since I'm paginating through the restaurants, I am going to accept a page number, a page size, and then I want to return a promise. And this promise will be returning a pageable object of type restaurant. So I'll be returning a pageable of type restaurant, which the T that we have here in the pageable accepts the type. So now data will become an array of restaurants. So we have our find all method here that returns a pageable restaurant. And as you can see here, we have an error saying that it's missing an implementation, and that's because I've used class here instead of interface. So there we go. So I want also a find one method, and again this method will take an ID and return that particular restaurant. Again, I'm returning a promise. I also need a find by location. We'll have here the location that we are searching for. We'll have, again, this can be paginated, so we'll have our page number, and our page size. And this will return the same as above, a promise pageable of type restaurant. We'll have our search function, which again accepts a page number, the page size, and the search query string. And it will return as usual our promise pageable restaurant. And finally, we'll have a method to get all the menus for that particular restaurant, and we'll accept the restaurant ID, and we will return a list of menu, or a menu array in this case. Let's go ahead and import our menu, and that's it. So there we have our interface for our restaurant repository, or contract, as some of you guys might call it. So now, to implement this interface inside of my restaurant folder here, not inside the domain but inside the restaurant folder itself, I'm going to go ahead and create a data folder, and this will have those infrastructure related artifacts or objects. So inside of our data here, I am going to create another folder. I'm going to call that repository, and one more folder, and I'm going to call it models, where we'll have our data model representing our MongoDB documents. So now we'll create the restaurant repository. This will be the implementation. I'll use IMPL for now, or not. And this will be implementing our iRestaurant repository. We'll go ahead and create those methods. So now we have all our methods here ready to be implemented. And our first method is our find all method. But before we implement our methods, we will go ahead and create those MongoDB document models that will be using inside of our repository to interface with our Mongo database. So inside of our model, I am going to create a restaurant model. And for clarity's sake, I'm just going to rename it. I'm just going to add the model to the end of it so that we can differentiate it from our restaurant domain object. So here we have our restaurant model, and we'll go on ahead and export as an interface. And this interface will represent our restaurant document in MongoDB. So I'm going to say, and this will extend our MongoDB documents. In this case, import mongoose, then mongoose document. So I'll have to import all as mongoose from mongoose. So this will represent a single document in our MongoDB, and how that document will look in a sense. So our restaurant needs to have a name, and Mongo will automatically generate an ID for us, so we need not put an ID here. We need the type, we need a rating, we need a display image URL, and as the fields are described here, that's exactly how they will look in the MongoDB document. And we'll have our location, and we'll be using the MongoDB geospatial API to find restaurants within a particular location. So in order for this to work, we'll have to set up the coordinates for each restaurant, and then we'll use their GeoNear query to query those restaurants that are in those coordinates based on certain distance that we input. So we have that, and we'll have our address, and this will be of our domain address value object. So that is our restaurant interface, but we also need to create another interface. This interface will represent the restaurant model. Now, this restaurant model will extend the mongoose. And it's gonna be a paginate model of type restaurant document. Now, paginate model is not available because we are going to use a package, npm package known as mongoose paginate version 2 in order for us to have access or use it as our pagination plugin. So we'll go ahead and say npm install, and I think the name is mongoose paginate v2. Go ahead and install that, and as you can see, it cannot find it. So let me go ahead. I think this should be a common v. So mongoose paginate v2. Let me try that. And there it install it, but we also need the types. So I'm going to say install -d as a dev dependency at types. This will install the types so that we can have access to those types while using TypeScript. So there we have both install, and now we have access to our paginate model. Now this restaurant model that we use here, that extends our mongoose paginate model, is basically the model that will be used by the mongoose client to interface with the mongoose document or restaurant document inside of our mongoose database. And the setup might look somewhat weird to you guys, but that's how it works. So we create a document, or this represents our document, how it looks. the fields that we're storing, and this represents the model that the client will be using inside of our repository to access this document. And also, in order to set up all of that, we need to also configure our schema, how the schema will look. And the schema represents, in a sense, how the database will look for this document and different constraints on the database. So it represents database types and different constraints, whether something should be required or not. And we can add other logic to basically validate the kind of information that we are putting inside of our database. So we are going to create our restaurant schema. And I'm going to say this is going to be a new mongoose schema. So our database schema will basically look the same as our document, but we're going to have specific mongoose data types and constraints here to describe how the data is represented and what kind of validation is ran on the data as it is being written to the database. So we have our name, and we are going to tell it that it must be of type string. And as you can see, we use capital string here as opposed to the common string for our regular TypeScript type. So, and we're going to say, yes, this is required, true. And we are going to put a text index on it. And this is a MongoDB specific index, so that this text is now searchable. So we can have quick searches on our restaurant names when we implement our searching feature. We have our restaurant type, which is again string, and this is also required. And I'll go ahead and quickly enter the other fields and then describe what is happening. So now we have our schema set up here, our image URL, which is string required. We have our location and how this will be stored, which will be of type point schema, which I will describe that schema soon. Again, we set up all of this so that we can use their geospatial queries to quickly query restaurants that are within a specific location based on distance. And in order for that to work, we have to index our location by a 2D sphere index, which again, you can read this in the MongoDB documentation that is available at mongodb.com. We have our address here also, and there we have our address split into the different address fields and their different types and what is required. So all these are required, but the zone where I am, this particular field is not required, and therefore I did not set it. Bear in mind also that if you read more on Mongoose and how it works, that there are specific validations that we can enter here on each field. For example, I could have entered a validation that says that the street address, that the name should not be longer than, say, 10 characters. And that will run those validations while the data is being written and throw an error if it does not conform to what the schema says. But here, I need to create this point schema, which represents the coordinate system that Mongo will use to run those geospatial query. So I have gone ahead and created our point schema. And again, you can see it's a Mongo schema with the type of string, the default value of point. And this is important because the type here is really point, but Mongoose represent this as a enum, and we set the default value to point. But when this is stored in the MongoDB database, they know that what they're looking at here is of type point, so it will be used in geospatial queries. And we have our coordinates here, which again is our longitude and our latitude. So that's basically our point schema that is represented here for our location, so that we can have access to the geospatial query feature. And now that we have created both our schemas, we can tell our restaurant schema that we must use the plugin, and this plugin should be the pagination plugin, which is from the from the Mongoose paginate package that we just installed. And then we can export our restaurant schema so that it will be accessed in our repository. So we need to import now pagination. This will import from our Mongoose paginate v2 library. So there we have all our schema set up, our models, and our restaurant document that we'll now be using inside of our repository. So now inside of my restaurant repository, I'm going to go ahead and close these. I am going to open a new window. And on one side, I'm going to have my tests. On the other side, my method that I am testing and building out. So now I will go inside my test folder and create another folder called restaurant. Inside this folder, I'm going to create my data model. Then I'll create my repository. And here I'll create my test. So restaurant repository spec ts. I'm just gonna bring it on this side here. So now for my test, I am just gonna describe my test, which at the highest level I am testing the restaurant repository. And here I need a before. So I'm gonna set up my test dependencies. In this case, I need a client, which is the Mongoose client. In this case, our system under test will be our restaurant repository. So let me import mongoose from mongoose. Now inside of our before block, we need to instantiate our client. So this will be a new mongoose client. Then we need to configure our client connectivity. So I'm gonna use the connection string that I have in my .env file, and if you guys do not have that .env file, then you need to watch the previous videos from the back end about setting up a MongoDB client inside of MongoDB Atlas, so you can have access to that. So here is my connection string, which I am referring to from my env file here, and I am saying my client should connect using that connect string and some flags, URL parser, create index, and unified topology. Now I need to import .NET env from .NET, and then I need to say .NET env config in order for me to have access to that connection string. And so now I can initialize my system under test, which will be a new restaurant repository, and this will accept a client as the dependency. So here on our repository code, I am going to say that inside the constructor, it should accept a private read-only, and this will be a client of type mongoose. Now go ahead and import that. So there we have access to our client, or we are injecting the client into our repository through the constructor. So then I'm gonna have an after each block, and in this case I want after each block to disconnect from the client. Now let me go ahead and describe the method that I am testing. In this case, it is the find all method. And this now can have its own before and after hooks. So I want to say before each, it's going to be an async method I'm passing here, and I want to say await prepare the database using the client. So this will be a helper method that I will create that will basically add some records to the MongoDB database so that we can use those records for testing. And in a sense, this is integration testing and not necessarily unit testing, but we'll be adding a small sample size of records, so it won't take that long to execute each test. And inside of our after each, I am going to say clean up the database. Now for these methods, I am going to go inside of my test inside of restaurant data, and I'm gonna create a folder called helpers. Create a file called helpers. And here I'll add those methods to prepare and clean up the database. So what I'm going to do first is to copy a JSON list of restaurants that I already have prepared. So it's basically just a JSON of restaurants, and these will be written to the database. So I have this list of restaurants, and I'm going to create that prepare database method. So I'm going to say export prepare db. This will equal to a async method that accepts a Mongoose client. And for this function basically will operate in terms of connecting to the database the same way our find all method will connect. So in order to connect, we'll have to first instantiate the model, in this case the restaurant model. So I'm gonna say client. I'm gonna say the model should be the restaurant. This should be the restaurant document that we created in our model folder. And it would have been best if I call it doc. So I'm gonna rename it to doc. I'll update that in the model soon. And then this is the name of the actual document in MongoDB, or from a relational perspective, the actual table. So we have the restaurant, and then we need the schema also. So we pass the restaurant schema, and then we are going to cast this model as a restaurant model. So we are telling Mongo that this is a restaurant model that we are operating with. Now inside of our restaurant model, I'm gonna change this from restaurant to restaurant doc. Here also restaurant doc or document. So now here I'm creating a model of type restaurant doc, and cast it as the restaurant model that we have created, so that we'll have access to those fields using our IntelliSense. Now, this is we setting up the client. So now we have access to our Mongo database through the client. And one of the first things I want to do at first, I find that if I do not do at first, it continually throws index related issues, even though I have set up the index on the schema. So the first thing I tell the model to do is to ensure indexes, and this will wait until all the indexes have been created successfully. And after the indexes were created, then I can say return await client insert many, not client, model rather, model insert many, and in this case restaurants, which is my list of restaurants. So that is my prepareDB function, and the cleanDB is dissimilar or simpler. Cleanup DB. And all this does is to tell the client to client DB say drop collection. So it is client connection DB drop collection, and you give it the name of the collection, which in this case is restaurants. So I'm telling it to drop those collections in this case, or erase that collection. So we are cleaning up the DB after. So this is our helper or two helper methods here. So back to our test file, we are saying, listen, before we run any test relating to this method, first thing, prepare the DB, insert some records. And after we have executed all the tests, clean up the DB by dropping all those collections. So we are operating on a fresh DB each time. Now, my first test, I'm gonna say it and I'm gonna say it should return restaurants. So now I am going to say, okay, result should be that I call system under test, which is our restaurant repository. I'm going to say find all, and page 1, page size 2, and I'm going to say my expectation is that the result to not be empty. And also my expectation is that the result data, since it's returning a pageable, should have a data length equal 2. So it should return 2 restaurants based on our page size. So we import that from Chai, And so here we have our test. So we are going to implement our method in order to get this test passing. So if we should run this as it is, we should get an failing test. And if you run the test now, you should see that nothing happens, as it is throwing an error in the background. Try to debug that error, and the error has to do with instantiating the mongoose client here. So here I have to remove the all so that it can get access to this mongoose object to instantiate it. So if I should run the test again, we see now that the test is failing with method not implemented. So that's our goal now, to implement that method to get our test passing. So now inside of our find all, we pretty much need to do firstly the same thing as we did here. So we can pretty much copy this code right here and paste it right here so that we can set up our model. So this client, and then we import all these as necessary. Now we have our model set up. So now we are going to set up some parameters for our pagination package, which will use these parameters to determine how to paginate the results. So we need to give it a page and also the page size. So the page size for it is called limit, so we need to pass our page size to the limit. And then we basically say page results model paginate, and we pass it an empty query filter and the page options. And I normally catch whatever error is returned and say return null. So if there's an error, I'll return null. This method is screaming out, so I'll make it async so that we can use the await keyword or operator. So now that we have our page results, I'm gonna say return, and I know that the other methods will be following a similar pattern that are returning pageable data. So I'm gonna create a function that will handle all those page data. So I'm gonna call this function restaurants from page results, and I'm gonna pass in the page results here. So now I'm gonna create that method here. It will be a private method, so I'm gonna say private restaurants from page results, and this will accept a page results, and this will be of type paginate results restaurant doc. Now this paginate result is inside the Mongo library. So here, again, instead of all, I'm going to say import each one that I want. So I want paginate results. Paginate result from mongoose, and also the mongoose object, which I can therefore then remove the qualifier there. And this will return null can be passed here also. So now, inside this method, first thing I'm gonna check if the page results, if that is null, or if it is not null but the documents in it, the length is 0, then I'm just gonna say return a promise reject. This will have an error message, restaurants not found. Otherwise, I'm gonna say results equal page results, and I'm going to say get access to the docs, and I'm going to map that into different, or a list of restaurants. In this case, it's our restaurant domain object. Get access to that model. Then I am going to, for each model, I'm going to return a new restaurant, and I'm going to pass in for the ID, model ID, name, model name, type, model type, rating, display image, for the location, model, location, coordinates, and for the address, model, address. So we have an error here. Type is missing the following properties: longitude and latitude. So there's an issue with our model. So if we should check, for example, our schema, or model rather, if we should open that, looking at our location, we realize that it is using a built-in document location and not the location from our restaurant. So in this case, we need to import location. So it uses that location. Now you see the arrow. Is there no more? Great. So now we can go ahead after we have fetched all the restaurants from the docs. We can go ahead and return our pageable. So in this case, return our pageable restaurant. And our pageable would have the new pageable. Yes. Our pageable will have the page number. So we can get that from the page results. So page results page. We need the page size, which is the limit on the page results. And we need the total pages, which again is on the page results. Total pages. And then we need to pass in the list of restaurants, which is in this case is stored in the results variable. Since this is an optional field, so if it is not there, I'm gonna say 0. So the page will be set to 0 if there isn't any value in this page. So there we have it, and there we have our find all restaurants method, which is basically get set in the page options, call in the paginate method on the model, pass the page options, and then parse the return information. So now if we go back to our tests and we should run our test again, I am expecting that it should be passing. And there we have it, a passing test. Now this video has been gone quite a long time now, so I'm gonna stop here for now and to pick up in the next video. So if you like this kind of content, guys, like the video, share, subscribe, comment, let us grow our skills together as we try and create robust applications using quite a number of principles to create clean application that is easily maintain and extend. So thank you for watching and see you in the next video. Also, the code is available on GitHub if you would like to look on it and to catch up. See you in the next one, guys.